Hello everyone. Today I'm going to talk about how we can minimize the carbon footprint by using the rammed earth technique. First of all, everyone knows that the climate change affects hardly all around the world, causes several natural disasters, and maybe sometimes lead to the war. Unfortunately, the result of that to destroy our city. And after that, we rethink about how we can reconstruct our city. And the reconstruction process itself, it's more difficult than the normal construction because we need to deal with the rubble, we need to deal with the waste. And the construction sector itself has consumed a lot of energy in different stage. First one, when we need to produce a material, we need to consume a lot of energy. After that, we think about the transportation, transit this material from the producer to the consumer. The other things is it's the construction process itself. After that, we need to think about the life cycle of our building because we need to consume energy. As a result, the construction sector causes more than 20% of carbon dioxide. So I start ask how we can minimize the carbon footprint in reconstruction process. I found that we need to deal with material. Material, it has a major impact. We need to find sustainable environmental material, which don't need a lot of energy and don't produce high of carbon dioxide. Another things about the technique which we need to use during the construction process and thinking about the consumption of energy after the building finish. So my solution, it was using rammed earth. What is the rammed earth? Rammed earth is a technology for construction foundation, floors, and wall using natural materials such as soil, chalk, silt, lime, or grass. In rammed earth, we are concerned about some material like gravel, sand, silt, and clay, which is inside the soil. There are two mechanisms make rammed earth hold together. We are looked about two features in the soil itself. The first one is the boundary between the material. The second one is the clay. There are some features we need to look at between the boundary between the material, the volume of the material, and the quality of the clay. Not all the soil can used in the rammed earth. For this reason, we have two types of rammed earth: unstabilized and stabilized rammed earth. The first one, it's use raw material, just soil, without adding any blending material. The second one, which is stabilized, we need to add some blending material like cement. To determine that, we need to make some simple tests, and sometimes we need to make some controlled tests. This test help us to define if the soil need to adding some blending material or not. For this reason, I start to look about some research about different type of soil. And I found a study in San Luis Obses, which used three different type of soil, which is the clay sand, dark yellow brown, and sandy clay. This type of soil needed to add some cement. It's about 7%. And the result, as I mentioned, it's not acceptable for all the soil. Some of them, it's get require code, another it doesn't. After that, I start ask myself, can we use another material? Can we add organic material in stabilized or unstabilized rammed earth? And I find the study talk about that. They made different mixture with adding cement and without adding cement, stabilized and unstabilized. And sometimes they use organic material like dung. And the result from this mixture, The best one is the A, which use it stabilize rammed earth with adding some cement. Another thing or another concern in my study was about the rubble. Can we use the rubble in reconstruction process? Actually, we can use the rubble, but we need to design our soil by ourselves, because when we use the normal soil with the rubble, we don't get a high result. But when we use with the designed soil, which we are call it enriched soil, the result is acceptable. After that, I start asking about the waste. Can we use the plastic waste in this process? Actually, yes, we can use it, and it gets a high result than the normal soil or than adding the cement itself. We can using the fiber, and it will get us a high result. So when we look about the rammed earth, actually we look about the thermal behavior of this building. And I want to make a comparison between the rammed earth itself and between the concrete building. And we found that the rammed earth is better than concrete building, according to the study which made in Morocco. And I found that rammed earth doesn't lose head, and it's better than the concrete building according to the design. And there's some factor inside this study, but we are focused just about the material, and we found it's better than concrete. Another thing, we are start asking ourselves, can we use the isolated material with rammed earth? I found a study talk about the normal rammed earth without isolated material and other with isolated material. And I found, yes, we can use it, and sometimes we have to use it in some condition. So my conclusion of this study, we can reduce carbon emission in reconstruction stage, and we can use rubble and waste material in reconstruction process. And sometimes we need to think about the isolated material in rammed earth itself. Actually, it's better than concrete, but sometimes we need to add isolated material. Thank you for listening.